Hey everybody, this is going to be the study guide for Unit 2/3. I wanted to kind of merge these two topics because they were in my, I guess, binder that I was looking at earlier, where I lesson plan. Unit 2 and Unit 3 are both about differentiation and introducing all the different rules for differentiation. And so this study guide is going to be mostly informational, with like really formula-based or rule-based things that really don't need more explanation from me. I'll briefly go through each one, but things like power rule and product rule, you guys definitely remember. So I don't want to spend too much time on that in this video. What I do want to spend time talking about is, I guess, the context in which you'll see these things on the AP test. And so the first two boxes on this study guide are average rate of change and instantaneous rate of change, AROC and IROC. You might have heard me say that before in class. AROC is kind of like I like to call it the Algebra 1 slope. AROC, average rate of change. And all this is your slope formula, rise over run. And so the context you might see this problem in on the AP test is in approximating a derivative using a table or a graph. The average rate of change involves 2 points. Just like in Algebra 1, when you take a slope, you use rise over run, you need 2 points to do that because you have to go from one point to another. This is the same idea, average rate of change. And it's either, you can write it in many different ways, y2 minus y1 over x2 minus x1 is the basic idea here. That's your average rate of change. And you can see this in a couple of different contexts. And I'll create more videos with free response problems using the average rate of change. But on the AP test, you will explicitly see these words, average rate of change. Okay. If you see these explicit words, this is the guy that you're going to be using here. This is used to approximate the derivative or approximate the slope of some graph between 2 points. And so you could see that from a table or you could see it from a graph. But basically, the idea here is what you might see on a free response problem is you might see a graph with a curve on it, and it tells you to find the average rate of change between 2 points. So all you're doing really is you're connecting those 2 points with a straight line, and you're finding the slope of that straight line. So I'm just going to put slope of that straight line right there. Okay, that's the average rate of change between 2 points. So you're not really thinking about what's happening in between the 2 points. The average is, that flat line in between there. And you could see the same thing. They might just give you these 2 coordinates and you have to do that. So that's the average rate of change. Okay, instantaneous rate of change, on the other hand, is kind of what it sounds like at an instant, at a moment, what is the rate of change. So I'll use the same graph over here, something curved like this. Okay, the instantaneous rate of change is you're just picking 1 point and you're drawing this tangent line that touches just that 1 point of the graph. So just write that tangent line right there. Instantaneous rate of change is the slope of the tangent line. And the way you find this is you do the derivative straight up, f prime of x. And then whatever the x value is right here, you would plug in to that x coordinate right here, and it gives you some number. That's the slope of this tangent line right here. I'll go back to this previous box real quick. This line over here is called a secant line. May or may not show up on a free response problem, but I just want to at least put that vocabulary there so that in case you see the word secant line, you know what to do. Okay, so instantaneous rate of change is finding the slope at a point. And so the note I'll make here is take the derivative and then you plug in whatever x value. Plug in x coordinate into there. And that gives you the value of the slope, instantaneous rate of change. Okay, these next 4 boxes, pretty straightforward. Power rule, product rule, quotient rule, chain rule. Nothing new here. These are just the formulas. Main one to remember, chain rule, because that's the one that people most often forget, is when you have a function within a function. Make sure you apply the chain rule. Okay, and if you have questions about any one of these, just let me know. I've also included your trig derivatives as well as your inverse trig derivatives. I'd rather put them all down on this paper. I was considering not including these, but I'll leave them there just in case. Who knows if they show up. I want you to save time. You can quickly reference them if it shows up on the test. And then here's exponential or natural log derivatives as well. Okay, so for implicit differentiation, there's not really a formula I can tell you here. I guess I'll just have to put an example in here with just a small explanation. So you use implicit differentiation when your function, all right, use when, not the function, but the equation is not explicitly solved for y. So all the other rules you see up at top, you could use those if your function is explicitly solved for y, like it's y equals something in terms of x. Implicitly, you use this when the equation is not solved for y. I'll use the word explicitly. So that's why we call this implicit differentiation, because the equation is not explicitly solved for y. And so, for example, you could have something like xy plus 3x equals 10y squared, something like that. This equation is not explicitly solved for y because you have x's and y's on the same side and they're all mixed up. And I could try, but I may not be able to isolate y on one side and solve the equation out. So in this case, you can still take its derivative and find the slope, but you'll just need to use implicit differentiation. So right here, I'll work the example first, and then I'll write another statement down here just as a reminder. So when we implicitly derive, we still have to apply the same rules as we always do whenever we take a derivative. So right here, I have x and y being multiplied. And whenever we have multiplication in a regular function, we would have to use product rule. And so I would also have to use product rule right here, treating x as the first and y as the second. So derivative of the first times the second. So derivative of x is just 1 times the second, so 1y, plus, now we go back, derivative of the second times the first. So the first is just x, and now the derivative of y, you can write it in two different ways. You can either write y prime, or you can write it as dy dx. Either way, this is a placeholder for the slope. The derivative of y is dy dx, or y prime. So anytime I derive something with a y in it, this dy dx will show up. Now I have just a regular 3x. There's no y's here, so when I derive it, it's just going to be a regular power rule. So it's 3 as the derivative. The derivative of 3x is just a regular 3. And now in my last step, or the last term on the other side, 10y squared. This is a power rule, and it has a y in it. So I'm still going to apply the power rule and do 2 times 10, 20, y, subtract 1 from the exponent, so 20y to the power of 1. But now since I took the derivative of something with a y in it, I need to multiply it by dy dx, or y prime, however you write it. So now you notice that I have dy dx on the left and the right side. So what I would continue doing here is, now I need to isolate dy dx and solve this equation for dy dx by moving all of my other terms to the other side. Collect the dy dx terms on one side and move all the other terms to the other side. So this next step, I'm going to move a couple of things around at the same time. So I'm going to leave x dy dx over here, and I'm going to subtract 20y dy dx, so it ends up over here. So minus 20y dy dx. And now I'm going to move 1y and 3 to this side over here by subtracting them. So minus 1y minus 3. And now I would just continue and solve this out by factoring. So I would have dy dx, factoring that out since both of these terms have a dy dx. I would be left with x minus 20y on the inside, and then I would have negative y minus 3 on the other side. And my last step here would be to divide by this x minus 20y. So x minus 20y would end up over here. And now if you notice, I have dy dx is equal to this stuff over here. So now notice your derivative is in terms of both y and x. And so now all I need to, this is just my derivative here, y prime. Y prime is my derivative, or dy dx. So I'll put a y prime equals dy dx is equal to x minus 20y over here. And that's implicit differentiation. So this is just an example, but the key idea here is that you need to apply a dy dx when you derive anything with a y term in it. Whether it has a mixture of x's and y's like xy over here, this first term, or if it's just its plain term with just a y in it, you have to apply this dy dx. That's the chain rule, actually. That's what you're doing here. Okay, I'll stop right here. I will attach more videos in this section with free response questions as well as Khan Academy videos, just if you need more clarification on any of these skills.